You've learned how to multiply polynomials, but there are some cases where you have to do things just a little bit differently. Not more difficult, just differently. And if you are able to identify these two special cases, it will actually make multiplying and eventually factoring easier for you. So squaring a monomial. When you square a monomial, not a poly, a monomial, you simply give the exponent to each term in the monomial. So you can see here we had 5x, the whole term, squared, and that ends up just being 5 squared times x squared, which is 25x squared. You cannot do that though when you're squaring a polynomial. So in this case, you cannot just give the squared here to get this and here to get this. It doesn't work out that way. So when you're squaring a polynomial, like given here, you have to actually write it out as a binomial times a binomial. And then you're going to use the FOIL method to multiply the binomials. So you multiply, you combine your like terms, and that would actually be your answer. So if you look at what most people think is the answer here, you are missing that center term. So it's really important when you see this squared, you don't just think, oh, I give it to each term inside. You have to actually write it out as a binomial times a binomial and do the FOIL, do the math. So here are 3 examples. So x plus 7 squared is actually x plus 7 times x plus 7. X squared plus 7x plus 7x plus 49. X squared plus 14x plus 49. And I want you to look, let's see if you notice anything about the product and the terms here. Same thing here, if you notice anything about the product and the terms here. You can pause if you want to think about it for a second. So and in relationship to the middle term. So what happens is your middle term is simply the product of the coefficients inside times 2. So the product of the coefficients in here, this has a coefficient of 1, this has a coefficient of 7. The product of 7 times 2 is 14. This example over here, you have a coefficient of 5, a coefficient of 2, their product is 10, double it, and you get 20. So I'm going to show you, it's a little bit of a shortcut, how to do this without foiling. This squared is 9x squared. This squared is positive 25. That middle term is the product of these two, so 3 times negative 5, which is negative 15, times 2, which is 30. So you take those two, multiply them together, and then times 2. Don't square them, times 2. And just to show you that that really does work, I will actually FOIL it out this time. So if we FOILed it, it would be 9. Well, let me write it out for you the whole way here. So 9x squared minus 15x minus 15x, and I did do this wrong. This should be a subtract. I think I said it, but I wrote it wrong. Plus 25. 9x squared minus 30x plus 25. So it's the same thing. So over here, let's try this again. Square this, you get 36r squared. Square this, you get plus 4. Multiply these two together, you get 12 times 2 is 24x, or in this case, it's an r. Now, if you don't like doing it that way, if you prefer writing out and doing all of the FOIL, please do that. The more work you show, honestly, the better. Just in some cases, some of you are able to see it and do it without writing out all the steps. But if your teacher asks you to show all your steps, then show all your steps. Okay, sometimes you have a sum and difference pattern. So this says when you multiply two binomials that are the same, with the exception of the addition subtraction sign, you only need to multiply the first and last terms because the middle terms will cancel out. Okay, so we only, in this case, you don't have to do the full FOIL. And if you look over here, this is why. These are identical except for this, and it only works if they are identical except for the signs. So when you FOIL, you get this, you get a 6x minus a 6x, and then here. This is always going to cancel out. So all you have to do when you see something like this is square the first and the last terms. Or I'm sorry, multiply the first and last terms. So over here as an example, we know these are going to cancel out. So we only have to do this part of the FOIL. That's it. X squared minus 144. If you wanted to write the whole thing out to see why, you would have x squared minus 12x plus 12x minus 144. And this cancels. Here, first is x squared, last is minus 9. And your answers are always going to be a subtraction when you have the sum and difference pattern. Okay? Now down here we have a review of squaring a binomial. And this one I'll write out the right way, and I'll do the full FOIL. And the next one I will do the quicker way with the doubling of the product on the inside. Okay, over here, I'll still write the whole thing out. So negative 2x squared is going to give me 4x squared. Then negative 5 squared gives me positive 25. But if I multiply these together, negative 2 times negative 5 is positive 10, times 2 is positive 20x. Okay, now this is not something you're going to be doing often, but still mental math, you're not always going to have a calculator. Sometimes you don't want to write things out. So you can do this in your head sometimes. So if you have special products to find this, you can use it for mental math. So use special products to find the product of 16 and 24. Well, the idea is that you find a common number between them. In this case, that number is 20. 16 is 4 less than 20, and 24 is 4 more than 20. So rather than 16 times 20, you can write it out this way. And you're like, why on earth would I do that? Because some of you, many of you, this is easier to do in your brain. You know 20 times 20 is 400. You know 4 times 4 is 16. So if most of you can more quickly subtract 416 than you can multiply 16 by 24. So all that's happening here is you're using numbers instead of variables, and that's it. So let's look down here. The common number between these two is 30. 22 is 8 less than 30. And 38 is 8 more than 30. And they're not always going to both be equidistant distance apart. This is the difference. What you have right here is what we talked about right here, the sum and difference pattern. So you're not going to have those middle terms. So if you know 30 times 30, basically what you have here is 30 squared and then minus 8 squared. 30 times 30, you know that's 900. 8 squared is 64. And then a lot of you in your head can do pretty quickly that 900 minus 64 is 836. And if you wanted to check that out the long way, please do so. Please use your calculator, and you'll find that it is 836. This one right here, the common number would be 50. 47 is 3 less than 50, and 55 is 5 more than 50. In this case, you would have to write the whole thing out. So it wouldn't exactly be quicker, but for some of you it might be. So 50 times 50 is 250. 50 times 5, or I'm sorry, I did the 50 times 5 first on accident. So 50 squared is 2,500, not 250. but then we would add 250 because of our outside terms. And then you would subtract 150 and then minus 15. And in this type of problem, by the time you do all of this work, you probably could have just written it out the long way, but I'm just showing you as an example that it can be done. And we're going to just skip that last one. All right, so mixed review. There are 4 of these. I really recommend hitting pause, and I'm going to quickly go through the answers here. So this was the difference, the product, sum difference here. So all we have to do is multiply the first and the last, or square, I'm sorry, the first and last, or multiply. Here, you have to remember that you have to actually write this out. 16x squared. If I multiply these together, 4 times negative 6 is negative 24, times 2 is negative 48x, and then negative 6 times negative 6 is plus 36. Same thing down here, except this time I'm not going to write the whole thing out. I'm just going to say y squared plus 8y plus 16. And then describe how you can use special products to evaluate 42 squared. You would just do 40 plus 2 times 40 plus 2. So your 40 squared is 1600. And then you would add 80 and 80 and 4. So 1600 plus 160 plus 4 is 1764. So there you go. There are your special products when you are multiplying polynomials.